And it's my pleasure to introduce Kevin today. Kevin has an interesting and diverse background in both arts and sciences. Kevin received a Bachelor of Fine Arts at Pacific Lutheran University with a minor in art history. He is also an active community member at MES, and many of us know him as the coordinator for the MES Student Association, which is just one of many hats that he wears. And today we'll be hearing about his thesis research. So Kevin, please take it away.
Hello, my name is Kevin Lester, and I did my thesis research on the distribution, abundance, and seasonal variability of marine mammals in the Southwest Puget Sound. So in order to start out this project, I had to do a little bit of research in how marine mammal stocks are being surveyed currently. Currently, aerial surveys are the #1 technique that are used. So a helicopter or a plane flies over a region, and then they count the number of animals that they photograph using a belly-mounted camera. Land-based and radio tagging surveys are used to learn more about the behavior of the animals. So after you get that count, you're able to correct for the number of animals that you missed based on what you know about their behavior. Thus, abundance is a calculated estimation with these methods. And for seals, the correction value is 1.53. So the number of seals that are counted in an aerial survey over a region is multiplied by this 1.53 to find the total number of seals that are estimated to be there. And one interesting fact is that no NOAA-respected harbor seal surveys have been conducted since 1999. This adds to the significance. NOAA, the National Oceanic and Atmospheric Administration, is tasked with managing marine mammal stocks, and so they're not managing a population that they know much about currently. And on top of that, there's no studies into their local distribution. And in the South Sound, the harbor seals have been shown to be genetically distinct enough to be considered a separate stock and managed as a separate stock. So their management techniques are slightly different. So a couple of research questions drove this thesis forward. The first of which is, how do environmental factors such as season and human activity affect marine mammal distribution in the Southwest Puget Sound? And approximately how many individuals from each species inhabit the region? Across the top, you can see pictures of the 4 species that were observed: the long-beaked common dolphin, harbor seal, California sea lion, and harbor porpoise. In this presentation, I'll be talking a lot about hauled out and in-water data points. So the California sea lion picture is a picture of seals that are hauled out onto a platform, and the harbor seal picture is an in-water data point. The methods that were used was a ship-based survey. So I got on a ship and I divided a region into 13 areas. Each area was surveyed three times per season, and I did this for 3 seasons. And a 100% count was attempted, or a census. The data was collected mobilely using a mobile device, and the data was then analyzed using GIS and Excel software. The types of data that was recorded was the date, time, and location of species, environmental conditions, and human activity. The materials used was an old 1977 20-foot sailboat equipped with a 9.9 outboard, which gave it a cruising speed of 5 knots. In shallow waters, a 10-foot kayak was used, paddled at 2.5 knots, and utilized mobile environmental recording devices. The software used was Esri Survey 123 for collecting data mobily. And then that data was refined and visualized using Microsoft Excel and Esri ArcGIS Pro. A couple of design considerations during the survey was that I, the observer, stood on the tallest point on deck and surveyed in a 360 degrees survey area visually. And then volunteers navigated the vessel using a set path on Navionics. The scope is narrowed to all the waters between Hammersley and Nisqually Reach, and the seasons took place in June, September, and December, or summer, fall, and winter. Some legal considerations also shaped the survey. The Marine Mammal Protection Act sets forth very strict guidelines on how to view marine mammals, and industrial or restricted waters here is an example of the Survey 123 decision tree. And on the right, you can see the biases that were accounted for and their mitigation techniques. Here are the maps of the survey region. On the left, you can see the different survey areas with the kayak survey regions in colored hashed out marks. So most of those are in the inlets, at the end of the inlets. And then the solid colors represent the deep water areas. On the right, you can see the exact routes that were used. So the kayak routes are these dashed lines, and the deep water areas are these solid lines. Sometimes multiple areas were done in a single day, depending on the size and location of where it started. For analysis, tools in Excel included R-scripting test for significant relationships. GIS tools included band collection statistics on raster data sets, or basically like pixel maps, to compare the different seasons distributions. Depth class, satellite imagery was converted into a depth class raster, which was then imprinted on the data so that all the data sets had a depth value. And then heat map symbology was used to visualize the concentrations of the different data points. So let's get into the results from the survey. You can see here is the distribution map that I generated from harbor porpoise observations. More harbor porpoises were observed in winter with an average count of 24 per season, or 24 per lap. And then they were also observed to be in deeper waters around Case Inlet, mostly. One thing to note with this type of visualization is that the warmer the color, the more individuals are in that location, proportionally. So here you can see in Butt Inlet are single points that are probably a single individual that was observed there during the survey with the very blue circle. And then here in the Pickering and the Pele Passage in South Pickering area is a very bright spot, which is probably several harbor porpoises traveling together. California sea lions were observed only in significant numbers in winter, with a group of 20 or so in feeding off of the west coast of Heron Island here in the middle of Case Inlet. This group of 20 or so sea lions was followed by harbor seals, gulls, and harbor porpoises, all feeding in the same area. Long-beaked common dolphins were also observed in Case Inlet, but in the northern part, also off the coast of Heron Island. This is weird because long-beaked common dolphins are native to Baja California, but this small group of dolphins have occupied the South Sound for the past 10 or so years. Harbor seals were observed in significant numbers across all seasons. However, in the fall, they were observed the most. We'll get into later why this might be, and looking at the different concentrations for each season kind of gives you a hint at why that might be. In fall and summer, you can see the seals are concentrated around these three spots, which are the major haul-out areas, or congregated out of water. In the winter, you can see that they're concentrated in the deep waters of Case Inlet and in the deeper waters of Butt Bay, or Butt Inlet. So to reiterate, they were observed across all seasons in very significant numbers. The max haul out was in fall, and looking at here the counts in this table below, you can see the breakdown of the in-water total and the hauled out total. So I reverse engineered the correction value using the hauled out total and the in-water total to find the total, the overall total. So you would multiply 6.25 by 1.59 to find the overall total. This is very close to the NOAA correction value that is used for harbor seals in the region. Here is a map of the major and minor haulouts in the region. You can see the major haulout is in Henderson Inlet. The second largest is Carline Beach Private Marina. And the third largest is the Olympia log booms. This second largest one was not mentioned in any of the literature, so I can't compare my results of other haulout numbers to numbers in the literature, because in the literature, this doesn't exist. This largest haulout is a DNR preserved area. They were also never observed to be hauled out on land, despite the survey routes designed to detect that. So looking at these concentrations, I compared the distribution of harbor seals to various environmental factors. And the most significant environmental factor to predict their distribution was depth class. So here you can see a graph of all the depth classes equalized by the amount of area they would take up. And the number of seals observed in those areas were multiplied by the same power number. So this is a simulated count as if I had surveyed all these depth classes in equal area. You can see in the winter that the seals prefer deeper waters, and in fall and summer they have a very similar distribution and prefer shallow waters. Winter was the least similar, and this is backed up by the band collection statistics analysis tool in GIS, where winter was observed or was calculated to be the least similar out of all the comparisons, whereas fall and summer are the most similar. Other environmental factors that were considered were surface water temperature. So this is a map of the surface water temperature of the region. The R-squared values are very low and very insignificant, so it did not appear to have an effect on distribution. Boat traffic also didn't have a significant impact on distribution, although in the summer, there is a practically significant value, although this could be for any reason. Probably because seals are hauled out near marinas more so, and there was a lot of boat traffic in the summer. So there's a lot of variables to consider. For future research, I would love to get the permits to survey in all the locations in the region, including the protected areas, and to complete a full South Sound ecoregion survey so that I can compare it with NOAA results directly. Some future equipment that would be nice is a vessel capable of shallow and deep water surveying, which means I wouldn't have to vary my methodology between the different areas. Also, those vessels would be nice to have better data collection devices such as a mobile weather station, drones, radio tagging equipment, and all the permits that go along with that, so that I can learn a lot more about the behavior of these animals that I'm counting. Some of the limitations of this survey is that the vessel was in need of constant repairs, and this was very taxing on me. Volunteers were not experienced navigators, although they followed the navionics route pretty well. Deep and shallow water surveys use different methodology. However, the findings there were fairly consistent with what was observed in directly adjacent areas. And this is only a survey of daytime activity of marine mammals. So the nighttime activity is still unknown to me. The main takeaways of this research is that distribution is highly variable, and similar correction value means that I did a thorough count, because it's fairly easy to count all the seals hauled out on land. However, it's hard to count all the seals in the water, but because the correction value came out to be the same as the NOAA estimated correction value, it means that I probably counted almost all the seals. And because the correction value isn't far off from the NOAA value, it means that I didn't disturb the seals as much as an aerial survey would, or disturb them as much, because otherwise they would have a lot of in-water data points and not a lot of hauled out data points. And then the third point is that surveying harbor seals is still a viable method by ship as long as biases are kept in mind and respected. I want to give a special thanks to the faculty at Evergreen that helped me design the survey, as well as Pacific Mammal Research in Anacortes. I'd like to thank the Dead family for selling me their beloved sailboat, and the Newman family and the MES Thesis Fund for funding this very ambitious project. Thank you.
All right, thanks, Kevin. Okay.